Okay. Okay, boys and girls, today we're talking about the one 4.3 density and pressure. Okay, so basically the density here, 1, 2, 3, until 3 is quite basic, is what we know. Density is mass per unit volume. Okay, so at here in our AS, actually, they want you to know how to using the volume for these two cases, cylinder and sphere. Normally in our IG or SPM, they were just like a very simple cube or rectangle, something like that. So it's quite easy lah. The width times height, the width times length, something like this, we already know, times height is the volume. So at AS, there were questions might be involved with cylinder or sphere. So these two formula you have to know, but I think should be no problem because this is basic mathematics. Okay. So at here, mass divided by volume. So kg per meter cube, density unit is kg per meter cube. Okay, so at here, the gas are less dense than liquid, which are less dense than solid. So actually, solid is the denser, followed by liquid, then followed by gas. Okay, so if less dense or we say lower density, then it will be float. Okay, so why gas is less dense is because fewer particle. Okay, so the mass at here, this one is smaller. Since same the volume are the same, then the mass of the particle, because less particle, so the mass will decrease, of course density will decrease. So this one is less dense, okay, less density, lower density. Okay, so at here in our AS, volume might be not always giving you directly. Okay, maybe they're not giving to you, so we have to calculate it. So you have to know the formula. Okay, for the volume, what is the formula for the volume of cylinder? What is the formula for sphere? Okay, so one more in AS they will might be asking is about mixture. The liquid and liquid, different type of liquid, we mix it. Then at the end, how you find the total overall density. So you have to find the mass, add it up together. You have to find the V, made it up together. Okay, so at here, the mass, they might be not giving you directly. So you have to using this density formula to find out the mass. Okay, so later on the questions in page number 2, okay, we will learn. So we go to your page number 2. We try with this question. Different here we got 3 different density. Okay. In a large container, in an in a large container in an oil refinery, 3 oils with different density are mixed. Okay, so this is what we say. No chemical activity occurs. The mixture consists of, so we have 3 lah. Okay, 1, 2, 3. What is the mixture? So at here, just now I got mentioned, density in total mixture actually will be the total mass divided by total volume. Okay, total mass easy. You can just get like this. Okay, from here 1,200, 1,500, and 4,000. But you don't know the volume. So what you need to do is you calculate their volume out first. Okay, so this one. Okay, I need you guys calculate the volume. Each of the volume you need to calculate out. Okay, so this one calculate volume, volume, volume. Okay, do you know how to calculate? Using the density formula. Density is mass divided by volume. So you want to find the volume should be mass divided by density. So this is the mass, this is the density. Like boys and girls, do calculation V1, V2, V3. Then find out the total M1, M2, M3. Add it up together. Calculate what is your density of the mixture. Okay, then type your answer in the chat box. Can I do it right now? Fatima, answer? Hmm? No eh. Try again. See any part you do calculating wrongly or not. Vashini correct. How about others? Let me see. Manjo correct. Okay, answer is A. Ideal answer is A. So total mass added up together plus 1,500 added up together 4,000. Okay, so you have to count. If for me, if not mistaken, I give the final answer A, correct, Fawal? So at here, the V1 that I get is 1.0909 meter cube. And this is 1.744 meter cube. Then this is 4.396 meter cube. This is my calculation, then I get this answer lah. So you check if you make mistake, then which part actually maybe you press your calculator wrongly. So this one is 1.0909 plus 1.744 plus 4.396. Your answer should be 927 kg per meter cube. Answer will be A. Okay, so at here, they give you the information not complete is okay. We're using the formula to find out the missing unknown variable. So we do total mass divided by total volume. That is the mixture density. Okay, so we goes to the number 2. Okay, this one, I give you some hints first, okay? Here, the full fat milk is made up of fat-free milk mixed with fat. So which means that at here, okay, we got the fat and also fat-free. Okay, two part. Okay, here. A volume of this of full fat. Okay, that means that full fat has a mass of total. So this is the total volume. Okay, so this is the total mass. Okay, it contains 4% of fat by volume. So that means that this is mass volume density. So 4% fat. 4% fat. That means that the fat at here 4% of the total volume. Okay, so you have to count lah. Okay, what is the what is the volume for the fat? Okay, then after that, density of the fat-free milk is 1 times 0.4 times 10 power of 3 kg per meter cube. Okay, so at here, the total mass, here, the total mass at here should be 1.035 kg. Okay, what information we can have? I guide you a bit. So first, this one you can count 4% of the total. Then 4% of the total, that means that this one you also can know. So I label step by step. So this one, number 1, you can count what is the volume for the fat-free part. Then after you getting this one is 96% of the total lah, okay? Then you can calculate number 2, you can get the mass. From the mass at here, you can get the mass of the fat. Then from the mass of the fat, you can calculate the density of the fat. So the questions, they only give you, seems like giving you two value here. 4% of the total, then density, total volume, total mass. Okay, so here total volume. So this one I can write is 1 times 10 power of negative 3. Okay, so they want to calculate this. But we need to step by step to find the unknown physical quantity. So boys and girls, this is the hints that I can give you. You try to do calculation. What is the density of the fat? Do it right now and then type your answer to me. Okay. Any of you get the answer? Count the volume for the fat-free. Then because you got density and volume, so you can calculate the mass. Then you know the total mass. Of course, you can calculate back the fat mass for the fat. Okay, Jore, correct. B. Manjo, B. Yes, correct. How about others? Do you able to get D? B. B. Answer is B. Not D. B. Okay, so at here the here density for the fat free, because this information is more complete, so we can calculate this, is equals to the mass for the fat free divided by volume of the fat free. Okay, so at here is 1.04 times 10 power of 3. The mass at here, we don't know. We want to calculate fat-free mass. Then this one, the fat-free is 96%. So you can using 96% to times with the 1 times 10, 96%. You times with the 1 times 10 power of negative 3. So at the end, at here, the fat-free part, it should be, my answer is 0.9984 kg. This is my answer. So here, 0.899, not 8. Wait, 9984. Okay, so when I know the total, I know the fat-free mass. So of course, I can calculate the fat. The fat at here, mass for the fat. You're using 1.035 minus 0.9984. So my answer is 0.0366 kg. So here I get 0.0366. Okay, basically at here, this is only left the last step here. Okay, how to find the density? So density for the fat, mass for the fat divided by volume of the fat. So at here, the mass is 0.0366 divided by volume is 4% of the total. 1 times 10 power of negative 3. So at here, our answer should be 915 kg per meter cube. Our answer will be B. Right there, our answer will be B. Okay, let me have a look. Okay, so at here, look at this. Is there any questions? So you're using the volume. Okay, using the volume. So you can use the density to find back the mass. So from the mass at here, this is total mass. Then you find out the mass for the fat. And then from here, we can find out the density. So density at here is 915 times 10. Oh, okay. It changed to standard form. So it's 9.15 times 10 power of 2. So basically it's 915 lah, kg meter cube. Okay. During if you're using 4% of the mass, will you get the 0.0366 total mass? Okay, how about others? Check your answer whether you're able to get this question answer correctly or not. Okay, so cannot, you have to using the density, because the volume doesn't mean that you will get the same percentage of the mass. No. Okay, that's why we need to step by step to find using the density formula. Okay, so for these questions, I just put 2 questions. Behind self-practice, I think we got more questions about density. Yeah, you can practice. Okay, boys and girls, we goes to the pressure. Okay, we goes to the pressure. Pressure in our IG and our SPM is also simple. Pressure is force divided by area. Okay, so in our A level, we will add a little bit difficulty, which is the force axial is the mg, weight is the weight. Force is weight, weight is gravitational force. So weight is one type of force. Okay, so at here, we add one thing. The weight, the m at here, we using just now the density part. Okay, so just now the density is mass divided by volume. So how about the mass? Density times volume. So right now we adding this part. Okay, they don't want to give you the mass directly, they want you to calculate it. So this is the part that we have to know. Okay, so this part. Okay, so pressure unit is Pascal. If using the formula to derive the unit, it will be Newton per meter square. Okay, so at here, this one we know lah. If a force is spread over a larger area, it will cause a small pressure. Okay, so here over a larger area. Okay. So you're wearing sports shoe, wow, the pressure is very small. But if you're wearing the high heel shoes, you're trying to run in the field, you will find that you keep on sink in the field, okay? So sink into the mud. So this one is because high pressure. This one we already learned. Okay, we look at the past year, how and what kinds of question they will ask. Oh, we have block P, Q, R, and S and T. Oh, okay. But the first four, 1, 2, 3, 4, they're having the same density. Okay, the block T is twice density. That means that this is 2 like this. Okay, so this part is this. Okay, density is the same for the first four block. Last one is double. Okay, it's the double. Cross-sectional area and the height are shown. Which two blocks exert the same pressure on the ground? Okay. I guide you for the first block. First block, the pressure is the force divided by area. And what we say today, okay, in our A level, we were using this rho Vg over A. Rho Vg over A. So we involve with the density formula. Density formula. So this one, density is this. Okay, volume. So the volume at here, we can using rho area times the height. Area times the height is the volume. Then G divided by area. So at here, area and area can be cancelled out. So this, the first block, pressure actually is rho Hg. Okay, you're using the same way, do some substitution. I want to continue QRST. Then at the end, you compare A, B, C, D. Which one is the correct answer? They're having the same pressure on the ground. Now, dear, try. Rho Vg over A. You guys try. I goes to the toilet for a short while. Hey, I'm back. Farewell. No, farewell. Try again. The last one, block T, density is 2, double. Washini correct. Jore no. Jore no. Try again. Which part you do substitution wrongly? How about others? Prasan, how about you, Prasan? Manjo, Kaichin? Do substitution using the same way, then compare which one having the same pressure, A, B, C, D. Yes, Manjo, correct. Okay, boys and girls, answer will be donkey. Answer will be donkey. Okay, so here P equals to rho, so it's still rho. Then A is 2A. H G divided by A. So A and A cancel. So this one, the second one, A and A, oh, 2A. Oh, this one area also 2. Divided by 2. So this one is rho HG also. Block Q also rho HG. Okay, so basically P and Q having the same pressure, but ABCD we don't have this answer. Okay, so for this one, there is no space for me to write. P equals to rho, the area, H is 2HG divided by area. So this one, it will get 2 rho GH for this. Okay, how about this? This one is P equals to rho 2A 2HG divided by 2A. So 2A and 2A cancel out, 2 rho GH. So that means that block R and block S they're having the same pressure. But at here, we also don't have any answer A, B, C, D with block R and block S lah. We don't have, so there is no choice here. Okay, the last one. This one is 2 density. P equals to 2 double density than others. Area times the height times G. So this one divided by area. Cancel, cancel. So it's here 2 rho HG. Okay. So I highlight to let you see this one, this one. Okay, use another color. This one is the final density, final pressure. Okay, so after we compare, we will find that they say A, P, and T. No, P and T not the same. Okay, then B is Q and R. Q and R also not the same. Q and S also not the same. S and T. So answer should be donkey. Answer should be donkey. Any question? If no question, we are going to the next page, page 4. Any question? Right, boys and girls? Thank you, Washini. Thank you, Fawal. Thank you, Fatima. Okay, we go to your page 4. Page 4. Rectangular block of lead of density. So this is the density, have the side. Okay, be careful. This is cm, cm, cm. So at here, kg per meter cube. So remember later on when you do substitution, you have to convert cm to m. Okay, what is the maximum pressure the block can exert? Okay, do it. This one standard. If you are IG level, you also can answer this question. But remember to convert the unit to the correct unit lah. Okay, we need to convert to meter is because the unit of the density given is kg per meter cube. Okay, do it. Wow, Prasan very fast. Correct, Prasan, correct. Prasan, you try question number 3. Without I guide you, see whether you're able to get the answer or not. Okay, how about the others? You try maximum pressure. If maximum pressure means that the area should be minimum. So the rectangular block, you have to think. You need to using what surface, which side, okay, to be rest on the surface. Washini, correct. If you're able to get the answer, you goes to number 3 and try. Jore, correct. Manjole, Kai Qian, Boyang, Fatima. Tell me your answer, Jahan. Jahan. Manjo, correct. Okay. Manjo, correct. Answer will be donkey. Okay, answer will be donkey. So we're still using this formula. Density 1.13 times 10 power 4. The volume. So volume is the three side with times the length times the width times the height. So it's 0.12 times 0.15 times 0.1. G is 9.81. Okay, the area. We need to choose the minimum area so that we can create a maximum pressure. Okay, so minimum area at here we choose 10 cm and 12 cm. Okay, this surface. So 0.1 times 0.12. So your answer at here should be 16.6 kilopascal. Kilo meaning that times 10 power of 3, times 10 power of 3. So this question should be answered donkey. Okay, question number 2 should be donkey. Question number 3, a bit tricky, but you guys can try. Okay, number 3, you have to try. Oh, Prasan, not bad. Not bad. Correct, your answer is correct. Jore, not correct. You have to try. Oh, Jore, wait. Oh, yeah. I saw your answer. Your new message. Correct, Jore, correct. Oh, not bad, you guys. Vashini, correct. Okay, we wait for others try. Correct, Manjo. Oh, you guys are so smart, I thought this question will trick you. Okay, that means that you're very clear on the surface area. Okay, if you get stuck or you get the wrong answer, maybe it's because of the area. Okay, so at here, this one is the hemisphere, total volume of a sphere. So nice. They give you the formula, but don't expect that every time will give you. They can expect that you know about this, volume. Okay, Farwell, correct. Good job. Okay, so at here, we can calculate P pressure, average pressure. So pressure is the force divided by area, or here, rho Vg over A. So you have to count the volume. Okay, so density at here times the volume. Volume actually is 1/2 because this is hemisphere. Hemisphere, that means the half. So 1/2 times 4/3 pi r cube. Okay, so this one times the G. So divided by area. So what is your area? Area at here, if we look from the top view, okay, if we look from the top view, actually it is racing in this way. Okay, this is from the side view. This is from the top view. So this will be your area. Okay, this part will be your area. So your area should be pi r square. So this area should be pi r square. Okay, so if you can answer correctly, that means that you are very clear on the picture. So here, this one equals to the 2/3 rho rg, or just rearrange rho rg. Okay. Okay, settle. So answer is donkey. Here actually is just testing on you. Do you know that volume have to half of it? Do you know that area is pi r square? Okay, good job. Right, boys and girls, we go to page number 5. Page number 5, 4A, you try. Can you show that the mass? So I goes to page number 5. Okay. So they give you the base area, the high density. Can you show that the mass is 0.85 kg? If I'm too fast, you can type in the chat box and tell me go back to the which page for you to have a look again. I worry some of them maybe not yet finished. Okay, we already goes to the next page. Okay, now boys and girls. First one, try using the density formula. So do you able to prove that the mass is 0.85 kg? Be careful with the unit always. In our A level, they like to give you different units, so you have to convert it. Only use the formula. So here, kg per meter cube. So all the cm we have to change and convert it into meter. For A, do you able to count it? 0.85 kg. Good job, Washini. How about others? Volume is the area. Oh, okay. So at here, do you know how to convert to meter square? You have to know mathematics. Okay lah, mathematics you also know. Okay. So here 24 times 10 power of negative 4. Okay. So this one assume that you already know because this is basic of mathematics times the height is 0.045. Okay, so your mass should be 0.85 kg. Okay, boys and girls, you try for B. Try for B. Question B. This is the weight. You want to count the pressure. You have to know the force acting on the surface, which means that you have to know this. W cos 40 degree. This is 40. Okay. So you have to using the force by calculating this W cos 40. This one last time we already got mentioned why that angle is 40. This is 40. So that means that here will be 90 degree minus 40 lah. So which means that 50. Let me put it here 50. Let's say this is 50. Okay, then after that, this one from here to here is 90 degree. This is 90 degree. So here is 40 degree. Okay, so the angle you have to know is 40 degree. Make it two significant figure, Joray. Okay, your answer is correct, Joray. Lydia, any of you get the answer? Pressure is the force divided by area. The force for the pressure must be perpendicular to the surface, perpendicular to the surface. So that means that the force that we're calculating must be this perpendicular acting on the surface. Where is your surface? Here, this is your surface. Perpendicular to the surface, so you have to using W cos 40 degree as your force. So this one, W cos 40 degree divided by area. So where is the area? Oh, area is this. Okay, just now in A, area here, 24. 24 times 10 power of 4, negative 4. This one is meter square. Okay, so we convert it into meter square. W, what is the weight? Oh, the mass is 0.85. So we got the mass at here, so we can calculate the weight. So 0.85 times 9.81 cos 40 degree. Okay, then divided by the area, 24 times 10 power of negative 4. Okay, let me have a look. Yes, Vashini, correct. Manjo, correct. Yes, correct, dear. Pascal. Pascal. So this question is want to tell you that you need to know where to find the force. Okay. Force in pressure in solid is the perpendicular force to the surface. So the surface is my blue color line, surface. Okay. Perpendicular is my pink color highlighter there. So how I know this force? W is the weight. The weight is always pointing downward. So W cos 40 degree. Okay, so if no question, we go to your next page. How about others? Boyang, Fativa, Fawal, Jahan, Kai Qian, is it okay? Can we proceed? Type in the chat box. Let me know. Then we proceed to the page number 6. Okay. 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 Okay, good job. Thank you for responding. Okay, Lai Dion. Just now is the pressure in solid. How about pressure in liquid? Okay, fluid, that means that in liquid or in gas, actually is the weight of the fluid acting on that point. So we calculate the pressure lah. Okay, so if the fluid is at rest, all the points within the fluid are equilibrium. This one last time we already got mentioned. Equilibrium, that means that balance. Okay, the pressure will act in all directions. So no matter where, at any point, pressure is acting on it. Okay, so for this part, you have to, I make a start is because you have to know how to derive. Okay, in our O level, we just need to know using formula P equals to rho GH or rho HG. But at here, our A level, you have to know how we get this formula. Okay, so we're using the pressure and density formula and derive it. So look at here, density formula is mass equals to density times volume. Volume is area times the height. Areas times the height. So pressure is weight over area. The weight actually is mg. So at here mg. So we need to relate these two m. This m and this m. Okay, so we do substitution for the m. Okay, so rho ah. Then the g, not including the g. So like this. Okay, so at the end, area and area, we can cancel out. This one we can cancel out. So we get the formula rho Hg. This is how we get this formula. But in our A level, we never thought about this to you. We just tell you that, okay, the pressure in liquid will involve with this formula. But right now, in higher level, we have to know how to derive. So you have to know that we're using pressure and density. So we mix them, okay, here and substitute. Using the mass substitute in, so we get this formula. I make a star is because we have to know. Okay. The change in pressure can be found by considering the change in the height of the volume of the fluid above the lower surface. Okay. So this one, this one, I call it as depth lah. Okay, depth. Here also can call it as height. Okay, change in height, or we can call it a depth. Okay, so this one change, of course your pressure will be changed. Okay, so this is the change in pressure, can be considering the change in the height, can be found in considering the change in height. So this part change, the pressure difference will also change. Okay, we goes to your next page. This is just theory. Okay, if they say that pressure, they didn't mention about liquid pressure, they didn't specific liquid pressure, so you have to consider the atmospheric pressure. Okay, so if we look at this, if I draw like this is the liquid. Okay, inside this point, I have liquid pressure, and actually in actual readings, we still have atmospheric pressure. Okay, if they didn't mention liquid pressure, they said that pressure, what is the pressure at this point? Point X, let's say. So the point X, actually, you have to consider atmospheric pressure and the liquid pressure. Okay, so at here, this one, total pressure is the hydrostatic pressure, that means that liquid pressure plus the atmospheric pressure. Atmospheric pressure, this value no need to memorize, they will tell you. But roughly, we were using 1 times 10 power of 5 Pascal. No need so specific, so in detail. Okay, so roughly it's 1 times 10 power of 5. Okay, this one in SPM we learn. Okay, in IG we didn't learn. Okay, this is called manometer. It's used to measure pressure or measure the density for the two liquid. Okay, so at here you have to know if the liquid having the same liquid level, they having same pressure. Same liquid level, same pressure. Okay, so look at this one and this point. The blue color liquid, this is the same liquid, and then they're having the same liquid level. So these 2 points, let's say I say this is B point and A point. B point equals to A point. They are the same pressure. So we look overallly to the diagram. It's both arms exposed to the atmosphere. So they experience same atmospheric pressure acting on it. Okay, we look at the second case at here. You will found that now got difference. Okay, got different height. So we choose the lowest level here, this point B and point A. Okay, the liquid level, we choose the lowest part, then we draw a horizontal line. So you will know that this point, B and A, actually having same pressure because they're having same liquid level at this point. Same liquid level at this point. Okay, so at your point A at here, they will having the same pressure as point B. So what is the pressure at point B? Point B got two parts. The exposed to the air, this part is atmospheric pressure. And not only atmospheric pressure, but it also having the liquid pressure. So this is the liquid pressure. Okay, so you see point A equals to point B. So point A having the pressure, atmospheric pressure, plus the liquid pressure. Okay, so point A equals to point B. Point B at here we have atmospheric pressure plus liquid pressure. So point A also the same. Okay, case number 3, this one, you see got two different type of liquid. So this manometer can also help us to measure the density. Okay, so at here, same thing, same liquid, same type of liquid. We find the lowest point, then we draw a line, horizontal line. So that means that at here, this is point B, here is point A. Point B equals to point A, their pressure is equal. Okay, so point B at here, what we have? We have atmospheric pressure and we have the liquid pressure. The liquid pressure is rho GH. Okay, this one, rho GH and atmospheric pressure. Okay, the second part, point A. The right hand side, point A. It also having atmospheric pressure plus the liquid pressure. So we're using the orange color here, rho GH plus atmospheric pressure. But because atmospheric pressure and atmospheric pressure can be cancelled out, it's the same amount, can be cancelled out. G and G can cancel out. So at the end, rho BH1 can be equals to rho AH2. Okay, so at here, you will find that the H1 is lower height. Okay, smaller height. This smaller height means that density for the liquid B actually is higher density. Okay, density for B is higher density. So the H at here is smaller H, smaller height. How, what should I say? Okay, this one H1 is small. That means that this density is high. Okay, the H2 is high. That means that the density is smaller density. Okay, based on this, actually, we can count out the density lah. But in theory, we just roughly, we know that the shorter height, then the density will be higher. Okay, boys and girls, we do practice. Okay, theory sometimes is Density for the sea level. What is the pressure when 80 meter below? So this is your H. So at here, they didn't mention about liquid pressure. So you have to calculate the total. Somehow they already give you the atmospheric pressure. So do your calculation and tell me. Good job, Fawal. Prasan, correct. Vashini, correct. How about others? Total pressure. This is my answer. Okay. Okay, next. Question number 2. Question number 2. Let me draw the vertical length. Something like this. Vertical length. Sometimes we read it and then we try to draw some diagram easier. Okay, the length at here is 20 meter. Top. Oh, okay. This one from here to here is 8 meter. Okay, what is the pressure in difference? Difference in pressure between the top and the bottom. Pressure in different. I want to find the pressure at the top. Pressure at the bottom. Right there. Pressure at the top and pressure at the bottom. Then find the difference. Pressure in difference. Pressure at the bottom minus pressure at the top. Vashini correct. Fawal correct. Good job. How about others? Pressure at the top. Okay, bottom have a higher pressure. That's why we're using bottom minus the top. Jore correct. Manjo correct. Okay. So basically it's rho GH at the bottom minus the rho GH at the top. Okay, so you just do substitution 1050 times 9.81. So this one, the height difference, actually the height difference is 20. So your answer should be 206000 Pascal. Answer should be B. Okay, boys and girls, we go to the next page. Page number 8. Okay, page number 8 actually not difficult. It's just want to tell you that it linked to formula for the pressure in solid and pressure in liquid. This one settle. Question number 2 settle. So I goes to next page. Okay, here they give you area. So we find area. Then density, we label all the symbol. Then pressure, oh, this is force. Force, F. Okay, what is the depth? That means that H. So at here you found that they give you the force, area, density, and want you to find the H. Basically at here they involve with two formula, which is pressure in solid, another one is pressure in liquid. So pressure in solid is P equals to F over A. Pressure in liquid is P equals to rho GH. So at here, F over A equals to rho GH. Using this formula, then you do substitution, you will know what is your height. Like boys and girls, do calculation and then tell me. Okay, Vashini give the answer already. Answer will be A. This question not difficult. O level they also got this kind of question. Okay, they just want you to relate these two formula. Okay, pressure in solid can be a pressure in liquid because pressure in liquids we derive from pressure in solid what? Right? Derivation. Okay, Kai Chen A correct. So there we go to the next one. Okay, so for this one, A is trapped inside the glass tube. They want you to find the pressure in the A. They want to know about this pressure. Pressure in the A. Okay, so just now I told you the manometer. Okay, manometer, we find the liquid level, lower liquid level. So that means that we're using this point. Maybe I can label this is point A. Here is point B. Same liquid level. First information, I know that they're having same pressure at this point. Okay, then we have to look at the left-hand side. What is the pressure acting on point A? So first, it has atmospheric pressure acting on the surface, water surface. Then second, this is the liquid pressure. Liquid pressure, okay, liquid pressure, water pressure. Here they're using water, so water pressure. So at here, water pressure plus the atmospheric pressure actually is point A. This point A equals to point B. So point B at here, this one is a closed system. So it won't be affected by this part and this part. No, this is closed system. So at here, point B, what is the pressure? Pressure is the pressure A plus the pressure due to the liquid or water for the B point. Okay, B point, this is A point. So at here, you do some substitution and then you tell me your answer. Farewell, you means number 4? No. Number 4, no. Okay. So here, rho G H. So at here, the density for the water, they label density W. Rho W. Then the H. H is from the surface until the point. So it's HW. Plus, atmospheric pressure is P. They say this is P. Equals to the A plus the water, rho GH. Water is W, G is G, H at here. H at here, this is the H that I want for B. This is the H I want for A point. So what is the air pressure? What is the air pressure? Correct, Vashini, correct. Vashini, you may try to the next question. How about others? They're trying to trick you. The height for the liquid level for A point, they label at here. They label at the another side. So you must be very clear which height you want to use. Jore correct. Manjo correct. Okay, so boys and girls, this one I highlight using the blue color. The height that I use for point A is from the surface until the point. So they're trying to trick you. They label this one HM at the side. But this HM is not the H for us to find. Okay. So the HM at here actually is for the HB that we want to find. So if you rearrange it, you should get P plus rho GH minus rho GH M and M. Answer should be B, Dale. Answer should be B. Ah, yeah. Thank you, dear. For the okay, dear, I made mistake at here. Thank you. Who are you? The one, Manjo. Manjo, thank you. Like dear. Yeah, I do too fast. This one is the mercury. Thank you, Manjo. Mercury is M. Oh, this is the M. M. Okay, this is M. This is mercury, not water. It's mercury. Thank you, Manjo. Okay, the B point at here is the density of the mercury. This one, the dark gray. Okay, it's no water. Okay, so boys and girls goes to the next question. A, see, they ask you to derive and show how you get this formula. So just now we said that we're using the density, which is the mass is actually rho V density. So the pressure force acting on the area. So this one is mg divided by area, which is the rho Vg over area. So we're using rho V. V is A times Hg divided by A. Area cancel, so we get rho GH. So you need to know using what formula to derive. Here they didn't give you hints. If they give you hints, more easier using the pressure and the what density to derive. Okay, so they didn't mention, but we have to know we're using this density and pressure. Then we mix them, okay, substitute the M into the F equals to mg the part, okay. So this one, if you don't know, later on refer back to your worksheet notes. Okay, we go to the next part. The variation with height. Okay, this is the height of the total pressure on the base of the cylinder in A is shown in this diagram. So this is the diagram, okay. So with a height, with increasing the height, then the pressure will increase. Okay, so we go to the page number 10. Explain why the line 2.2 does not pass through origin. Okay, dear. Why when zero height? Okay, why I'm not going to start from the zero? Why? Any of you can type your answer and what you think. Why is not starting from zero? Why at zero, it still have 1 times 10 power of 5? Why we still have 1 times 10 power of 5? Thank you, Prasan. Good job. Yes, Fawa, correct. Because there is a atmospheric pressure. Jore, correct. Because there is atmospheric pressure. Yes. They are at here when zero. That means that at start at here, they start from here to going down. So at here, we still have the pressure 1 times 10 power of 5 is because there is atmospheric pressure. Okay, write down the answer. Because there is a pressure from the atmosphere. When H is 0. Okay, can you calculate the density of the liquid from the graph? Okay, last time I already told you that from graph, basically, from the basic knowledge that we're using the data and go up, go to the left to find some value reading, there is two things others than that. There is two things we can find, information we can find. One is from the gradient. Another one, it might be have some useful information when we find area under the graph. It depends, okay? So at here, first, gradient. Gradient at here is y divided by x. Okay? So at here, your y is pressure. Your x is hash. So the question just now, they're asking you to find the what density. Okay, pressure is rho g. They want density. Density, if I rearrange the formula, it will be P divided by GH. Am I right? Then how you relate and find information from this graph? So at here, we know that P divided by H, this is a gradient. This part is gradient. So at here, I rearrange P over H. times 1 over G. So boys and girls, for the questions, just now the questions, you have to find the gradients. This part is the gradient. Find the gradient times 1 over G. What is G? 9.81. Then you will get the answer for density. Okay, gradient, how you find? You can find any point. Maybe I using this triangle. Always remember, gradient, we're using triangle. Then this one, this point, we can choose this point is just nice. Don't forget that the pressure got times 10 power of 5. Okay, don't write 1 only, it's times 10, 1 times 10 power of 5. Then here is 1.5, 3 times 10 power of 5. Okay, like boys and girls, tell me your final answer. What is the density that you get? Vashini get the answer. Yes, correct. Good job, dear. How about others? Find your gradient is y divided by x. y2 minus y1 divided by x2 minus x1. Okay, so they ask you to get some information from the graph. We look at the gradient. Is there anything we can get? So we found that p divided by h. So from the formula there, we can calculate the gradient, then times 1 over g. Okay, for me, my answer for the gradient at here, my gradient will be 3 times 10 power of 5 minus 1 times 10 power of 5 divided by 1.5. So my gradient is 13333. Okay. So 13333 times 1 over 9.81. My final answer should be 1.4 times 10 power of 4 kg per meter cube. Or you just write like this also can. 1, 2, 3, 4 kg per meter cube. Okay, this is the answer. 14,000. Fawal make it two significant figure. Final answer, two significant figure. Actually can be accept 2 to 3 lah. But most of the time the answer scheme provided is 2. So we just make it the same as the answer scheme. Okay. One more question. Question number 6. Oh, I write extra 0. Yeah, I write extra 0. Sorry. Thank you, Manjo. 1, 2, 3. Yeah. Okay. Thank you. 14,000 is 14,000. Thank you, Manju. Okay, dear, goes to page number 10. Okay, goes to page number 10. This one, okay. So we got liquid density, fill a container to a depth hatch. Okay, depth. Depth means that we measure from the top going down. The liquid in the container is liquid L, so this is liquid L. The liquid M now is added, so we will add liquid M. Okay, the two liquid doesn't mix. The total depth is the 0.17, 0.17. Okay, 0.17 meter. Figure 2.2 show how the pressure P inside the liquid change with the height above the base of the container. That means that this graph, the measure is actually from the base going up. Okay, so the x actually starting from here. X equals to 0 is starting from here. They say that the height x above the base. So that means that x equals to 0, they start from here. So x equals to 0 actually is at the bottom part at here. So we look at the graph, look at it, is it make sense or not? You see the pressure when x equals to 0, the pressure is the highest pressure. The pressure is the highest. So when we look back here, this is atmospheric pressure. This is the pressure due to the liquid M. This is the pressure due to the liquid L. So of course at this point is the highest pressure because all the pressure acting on it. So it makes sense. In measure x equals to 0 at here, actually is at the bottom. They start from here going up until 0.17, until 0.17 here. Okay, here, can you tell me from the graph, what is your atmospheric pressure? What is your atmospheric pressure? Do you know what is your atmospheric pressure? No, Washini, no. Atmospheric pressure. At point X at here, the pressure at point X, pressure at point X at here, point bottom part, okay, of the M. Here actually is 9.25 times 10 power 4 Pascal. When X is 0, this is the pressure. Well, no, from the formula, not formula, from the graph. Jore, correct. From the graph, what is the atmospheric pressure right now? Jore, correct. Yes, correct, Fawal. Correct right now, from the graph. Prasan, no, this, from the graph at here, it might be going to some way. It's not sea level right now, we are. So you have to base on the graph at here. What is the atmospheric pressure? What is this pressure? From the graph. Oh, correct. No, Prasan, no, correct. Here, when x is 0, pressure is 9.25 times 10 power of 4. Then this is the point. Then after that, point at L, here, this part, okay, this point is 9.15 times 10 power of 4 Pascal. How about the atmospheric pressure? Actually is here. Okay, so answer should be 9.1, yeah, times 10 power of 4 Pascal. This is the point at surface, water surface of liquid surface, liquid M. Okay, at atmospheric pressure. This is the atmospheric pressure. So this one should be 9.1 times 10 power of 4 Pascal. So you have to think and trying to relate the graph with the actual picture. So the x is 0 actually is at the lowest point, lowest depth. Okay, Vashini correct. Then Kai Chen correct. Okay, then at here they ask you to calculate the density of liquid M. Density of liquid M, this part, they want to know the density of liquid M. So at here, how you find? P equals to rho GH. So at here, what is the pressure acting on liquid M? What is the pressure acting on liquid M? So basically here, I already label. Can you see that? At the lowest point at here, 9.25. Then at this point, 9.15. So you can find the pressure difference. You find the pressure difference equals to rho G, we have G. H, then you use finding out this H, finding out this H. Okay? So at here, Fawa, L is at the bottom. Ah? No, no. L is at the top. Eh, L is at the bottom. Oh. Yeah. Why? Today I'm so blur. Manjo correct me for 2 times, then Flower correct me for 1 time. Today I'm so blur. Okay, dear, thank you. My mistake. My mistake. Yes. L is at the bottom. This is at the bottom. At bottom, that's why higher pressure. At bottom, that's why higher pressure. I'm so shy. Sorry, dear. Yes, L is at the bottom. Okay, find the pressure difference. So you can using 9.25 times 10 power 4 minus 9.15 times 10 power 4 equals to the density, we don't know, 9.81 times the height. So what is the height at here? You can read it from the graph. So the height at here, it should be for the liquid M. Oh, okay, liquid M. Liquid M, that means that we have to, where? This one is 1.5 minus the atmospheric pressure. It should be using this pressure. Okay, so 0.15. So this one is 9.1. So this one, the H, it should be the height for this part, M. So this part, it should be 0.17 minus 0.1. Okay. So density is equals to, my answer here, 730 kg per meter cube. Liquid M. M is at the top, yes. Then after that, you find the pressure difference for the M part. Then you find the H for the N part. The behind is all self-practice. You have to practice by yourself. Okay, any question? If no, we are going to the lesson number 17. Worksheet 17. Thank you, Kai Qian. So, boys and girls, we go to the lesson number 17. Upthrust. Actually, it's related with the pressure also. Why we got upthrust is because there is a pressure difference. Okay, at the bottom part at here, we were having a higher force. And then, okay, here. Let me clean. Okay, upthrust. You have to know upthrust actually is another name called buoyant force. Okay, so buoyant force is upthrust is caused by the hydrostatic pressure as the depth increases. Okay, there is increase in pressure. Because of depth increases, so pressure increases. So we will create an upthrust. Then consider a rectangular box in a liquid. So this one rectangular, this is a cylinder. The bottom of the box is greater depth. So at this point, is greater depth. Can you see that H2 is greater depth than the top, H1? Okay. The pressure at the bottom part, of course, higher than the pressure at the top. So the resultant pressure will cause an upward force. So upthrust is because there is a pressure difference. Okay, the bottom part pressure is higher. So if we want to know how we get this formula for buoyant force, actually is here. The bottom part force minus the upper top force. Okay, the force from the top. So we minus it. That is a force difference. Okay, that is a buoyant force. So pressure is F divided by A, or we say F equals to PA. Okay, so buoyant force is P2A. 2 is the bottom, 1 is the top. Okay, P2A minus P1A. Then A surface area is the same, so we factorize it. So P2 minus P1. So pressure at here is rho GH. Pressure is rho GH. So we get this formula. H times A at here actually is the volume. So we get this formula. Buoyant force is rho GV. Okay, buoyant force formula we get is rho GV. It's because there is a pressure difference, and then bottom part pressure is higher, the upper part pressure is lower, so they create an upward force. So upthrust is actually an upward force, force acting upward. Okay, when there is a pressure difference between the lower surface and upper surface. So this is how we get this formula lah. Okay, in SPM we never derive. So right now you know how we get this formula. Okay, so we go to the next page. The upthrust at here is related with one principle called Archimedes. Okay, Archimedes principle. Archimedes said that when there is a fluid in a rest at rest. Okay, so boys and girls, an object submerged in a fluid at rest. At rest at here is means balance, or we say equilibrium. Okay, do you still remember about this? When we say balance, when we say equilibrium, that means that the upward force must be equal to the downward force. Okay, so what is our upward force at here? Is our buoyant force, or we say upthrust. Okay, so what is our downward force? Is the weight. As long as object is at equilibrium, at rest, floating. You saw the keyword of floating, also same thing, float. Okay, so there will be equilibrium. Upward force equals to downward force. So we get this. Okay, so the weight is the, just now we already learned, density times the volume is the mass of the object times the G actually equals to rho GV. Okay, the V at here is the volume immersed, this part, the volume that we immerse, this part, the volume, rho GV is this part. Okay, if not fully immersed, then we have to calculate the immersed part only. Okay, so we go to this question, partial questions. We have 4 cuboid. Okay, then we have identical length, the width times heights are immersed in the water. The cuboid are held, we holding it at same depth. If you holding it, that means that we not only have the upthrust, we not only having the weight, but we also having another force that we hold. So at here, we don't know how much force we hold it. So we cannot using this formula FB equals to weight, because there is another one more force that we holding. Okay, so at here, they're asking you which statement is correct. Okay, upthrust, that means that buoyant force. I write a small b, easier for us to differentiate. So buoyant force is rho GV. Okay, the density at here is the density of the liquid. Okay, surrounding this liquid. G is 9.81. V is the volume immersed. So we look at this. This is the liquid. This one is the immersed part. Okay, they're here. These 4 cuboid, although the material of them is 4 density, 2 density, and 0.5 density. But this is the density for the block, the cuboid. Density for the liquid, for them, they are in the same water. Okay, in the water, they're having the same liquid density. Okay, so at here, this one G. Okay, liquid, they are in the same water. So liquid water density are the same. So this one is same. G is a constant, is same. Volume immersed. So can you see that they are identical length, then width times height. So this one also the same. Although the material density are different, but doesn't matter. At here, the buoyant force is the density of the liquid times the G times the volume immersed. So at here, they should having the same upthrust force. Why I cannot using buoyant force equals to the weight, and from the weight there I study about the density of the object. Cannot is because we hold the block. So not only have weight, not only have upthrust force, there is still another force due to us. So we cannot using the weight of the object to count our buoyant force. So the only things that we can count is using this rho GV. And remember, this is density for liquid. This is the volume that immerse. Okay, is it okay? Like boys and girls, type in the chat box. Let me know. If okay, then we are going to proceed. Okay, Fawal, thank you. Vashini, thank you. Kaichen, okay, thank you. Manjo, okay. Manjo, there is no problem for you because you learn in your SPM. Okay, like dear. Okay, this one, buoyant force. So this one, you see, we hang the object in the air, is 10 Newton. We put it into the air, into the water. Why it becomes 7 Newton? Actually, it's 10 Newton, but at the end, it becomes 7 Newton. Where is the 3 Newton going? Actually, the 3 Newton going is because the water help you. The water push upward, it helping you. That is a buoyant force. So the buoyant force is 10 minus 7 is 3 Newton. This 3 Newton is the upward force due to the water. We call it as buoyant force. So apparently we lost 3 Newton. This is a buoyant force, 3 Newton. So if guys, I tell you, if you cannot, you are not strong enough, you want to do what princess heart of your girlfriend, you cannot get it, then you goes to the swimming pool. It will helping you. The water will helping you. But then you become a strong man. Okay, next slide, boys and girls. Here. Okay, relate the buoyant force to the weight of water displaced. Okay, starting actual reading, we got 0.7. Apparent weight after we put it inside, immersed into the water, we know that it only gets 0.4. That means that we lost 0.3 Newton. This is our buoyant force. Then if you observe to the balance, the water that we displace out, because this is the volume, so the volume will cause the water displace out at here. So we look at this balance, it's also showing you 0.3. So that means that your buoyant force will equal to the weight of liquid displaced. Okay, so this one 0.3 actually is your buoyant force. The weight of the liquid displaced actually is your buoyant force. Okay, then we look at this. This one at start, I haven't immersed inside the water. So of course there is no water come out. After that, maybe halfway immerse in. So this is the water that I get. Then I immerse, fully immerse, then I will get more water in what we say, displace out. Okay, so this volume of liquid displaced here, actually it will be equals to this volume. So if let's say here this volume of the liquid displaced is like, let's say 5 cm cube. So this one also 5 cm cube. I just roughly put some value. So these two value, the volume will be the same. Okay, so when we apply F equals to rho GV, this volume, I should measure this. I should measure the volume of liquid displaced or the volume of the object immersed. Okay, so for this volume, actually, I should measure this volume of liquid displaced or this one volume of object immersed. They are the same. Okay, then we are going to look at the page number 4. Right dear, we goes to page number 4. Is it okay? This is volume of object immersed, object immersed. Okay, here. This one, the derivation you can ignore lah. The main thing that I want to tell you, this one you can ignore, but if you are good enough, you can go a little bit in detail. Here, I want to have these two key points. I want to bring out this information. Upthrust on a floating object will increase due to the increase in depth. So when this part increase, your buoyant force will start to increase. So when we go to the 75%, so this one H of course will be increased. So H will increase, of course your buoyant force will start to increase again. So starting if haven't go in, okay, haven't immerse in, so your buoyant force is 0. Then we start to immerse in, so buoyant force will start to increase. 75 increase, then until 100%. When you 100% immerse in, this one, the upthrust will become maximum. So if you want to continue to go in further, actually the upthrust still the same. It's already maximum upthrust. So this is the information that I want to carry out. Okay, but I worry this one will make you confused. This is just want to show you that our buoyant force will be changed by the increase of this depth. But when you already fully immersed, it doesn't matter already. This H is a maximum. How? Actually, derivation at here, you can study a bit after that. So I want to let you know for this question, past year. So starting at the surface, it must be no upthrust. So it should be start from 0. So B will be wrong. It should be start from 0. So here, this one is correct. This one is correct, starting. Then when we immerse it, it should be start to increase until you fully immerse. Then the upthrust force actually is already maximum. It's already maximum. So you even go further, it will maintain at the maximum upthrust force. So for this graph, the correct answer it should be C. The correct answer should be C. Okay? Increase the upthrust when we start going down, okay, the hash. But when we already fully immerse, the upthrust force already achieved the maximum. Okay. Any question? If no, we are going to press. Why D cannot? Like this. We are increasing directly, dear. P equals to rho G H. The H and P, they are directly proportional. Directly proportional, Manjo. Directly proportional meaning that a straight line passing through origin must be a straight line. Okay. Like dear, if no question, we go to the past year questions, 2023. Okay, we want to observe the quality of water in the sea. We suspended by a vertical string. Then after that, the stationary float in equilibrium. Okay, dear, highlight. So this is what I told you. It balance. Okay, it is balance. Balance. Balance, that means that your upward force must be equal to your downward force. Everything balance. Okay, the sphere has a weight. So it going down, it has a weight 5 Newton. The prop and string have a weight. This one going down have 2 Newton. The density, so density of the seawater is 1.03 times 10 power 3. Upthrust, upthrust acting on this part, we ignore this part, the upthrust part. Okay, then after that, what is the volume of the sphere below? They want you to calculate what is the volume here. That immerse inside the below the surface of the sea. Okay, because of the float in equilibrium, so we understand that the buoyant force, wait, let me have a look. Yeah, buoyant force actually is rho GV. Okay, your buoyant force at here, there is a buoyant force for the sphere, but for the string we ignore. Okay, so this one is the buoyant force. The buoyant force actually is your weight, equals to your weight, because balance. So going down and going up is buoyant force, going down is we got 5 Newton and 2 Newton. So at here, first point you have to understand upward force equal to the downward force. Downward force is the weight. So at here, the weight we have 2, 5 plus 2. And then the buoyant force, upward force is density 1.03 times 10 power of 3. G is 9.81. So you calculate the volume. Okay, you calculate the volume. So this volume is the volume that we immerse. This volume is the volume that the object immersed in the sea level. So you do calculation. First point, upward force equals to downward. So your downward, you got 2 weight. Your downward, you got 2 weight. Then after that, you're using these two to make a formula. Rho GV equals to the 5 plus 2. Yes, Vashini correct. Fawal correct. Kai-Chen correct. Ooh, good job. Okay, the volume that we liquid displace actually is the volume of our object immersed. So at the end, if you do substitution, you will get D. Okay, this volume of object displaced actually is the volume of liquid displaced. It's the same thing. So how much the volume? What is the volume of the sphere? So this is the volume that we find. Okay, boys and girls, so it should be answer donkey. Okay, is it okay? Label all the forces. Label all the forces. Weight, 2 weight, and then upward force is the buoyant force. Maybe I can write like this. Weight equals to buoyant force. So weight equals to rho GV. Maybe like this is more easier for you to have a look. Okay, any other questions? Any of you facing any problem? If no, then we go to the question number 2. Is it okay? Question number 2. Prasan, is it okay? Okay, dear, we goes to number 2. Submarine with a total mass. So total mass, this one initially, this is the mass. And is arrest. Highlight, we find the keyword arrest. Arrest also the same thing that I told you is equilibrium. It's balance. Because arrest is means not moving. So here again and again, we get the information. Buoyant force equals to the weight. Okay, so first point, buoyant force equals to the weight. Weight is mg. Okay, so do you able to find out what is your buoyant force? From the first sentence, you already can find out what is your buoyant force. Okay, then total mass of submarine is suddenly decreased. Okay, because they pump out the water. Then after that, the upthrust force is unchanged. Therefore, just now the upthrust force that you calculate, the buoyant force, we have to find it out first. So although right now the mass suddenly decreased, but the buoyant force still remain unchanged. The change in the total weight cause it accelerate upwards. If it accelerate upwards, that means that upward force actually is bigger than the downward force. Therefore, it accelerates upwards. Okay, here they're asking you, so what is the initial upward acceleration? A. So at here, it related with force, it related with accelerations. We need to using F equals to ma. So you have to using the buoyant force minus your weight right now, new weight, because you already changed the mass. Then equals to ma. Like boys and girls, do your calculation and then tell me. Buoyant force still remain unchanged, but how we know the buoyant force? We calculate by using the first sentence because they at rest. So I know that buoyant force is equals to the weight. Okay? Then after that, decrease the mass, but the buoyant force still the same. So you're using the buoyant force minus the weight, the new weight, the decrease 200 kg. What is the new weight? Then equals to the m. M is the mass that decrease. Okay, so it's also new mass. Calculate the A. Why I need to using buoyant force minus the weight is because accelerate upwards. It accelerate upwards. Fawal correct. Good job. Fatima, no. Can try again. Manjo, no. Can try again. Buoyant force is 31392. This is my buoyant force. Kai Qian correct. Kai Qian. Okay, the new weight. New weight right now, starting is 3200. It decreased 200. So your new mass right now become 3000. So here 3000 times 9.81 is your new weight. Equals to the mass now become 3000 only. It's because we decreased 200 gram. So at here, your answer should be 0.654 ms negative 2. Your answer should be B. Now, Manjo, try to have a look which part you calculate wrongly. Always find the keyword at rest, stay horizontally, equilibrium, balance. Then you're using the formula buoyant force equals to the weight. Okay. New mass should be 3000 because right now it accelerate. So I think Fatima also the same because you're using the wrong M. Is it, Fatima? Yeah. Thank you, Manjo, for figure out what is the problem. Okay, so this one is your new mass. Okay, new things, everything new. Then after that, buoyant force remain. Then how we know buoyant force? Starting, the first sentence we already can count. Okay, like boys and girls, we goes to your page number 3. The sphere have a radius 3 cm and falling. Keyword falling, that means they're going down at a terminal velocity. Again, highlight the keyword terminal velocity. When we saw terminal velocity, meaning that constant speed. Constant speed means that balance. Okay, balance force. So this one is balance force again is because terminal velocity meaning that constant speed. Okay, still remember I told you balance force got two cases. One is object at rest or maybe object moving and then moving at constant speed. So based on this, I know that it is balance force. So upward force equals to downward force. Then the question said that the drag force is always opposed motion. They all oppose motion. So where is the direction of your drag force? You have to think. First, I highlight falling. So I telling you that it's going down. If you're going down, your drag force is oppose your motion. The drag force should be upward force. So I label drag force. Maybe F. Maybe we write drag lah. Okay. Why? Because of falling. Falling going down, drag force is going up. Okay. Then here, draw and label arrows to show the direction of 3 forces. Okay, so total we got 3 forces. Of course, this one is your weight. Every object have weight, always. Every object will have weight. So one more force. What is the force? That is what we learned today called upthrust force. Okay. So we got total 3 force at here. Label it. And the direction must be correct. Okay, the question said that next. Until here, okay? Already write down? Falling. So that means that it's going in this direction. Therefore, your drag force will be opposite to it. Okay, we goes to the here density of the liquid. This is the density. Can you show that the upthrust is 1 Newton? So upthrust is rho GV. 920 times 9.81. This one no problem. But the problem is volume. Teacher, what is the volume? Just now the lesson number 16, first page. Volume for the sphere. So you have to know. See, they didn't give you. So you have to know the volume for the sphere. It will be 4 over 3 pi r cubed. Okay, so you do substitution and see whether at the end you can get 1.0 Newton or not. We write 1.0 is because two significant figure. Don't write 1 only. 1 Newton is one significant figure. We write 1.0 is two significant figure. My boys and girls, do your calculation. Oh, the radius 3 cm. Remember to convert it into meter. Correct, Fawal. You got 1.0. Remember to write 0.0 because we want two significant figure for the answer. Okay, so this one, another one more time, show you that you have to know the volume for the cylinder, volume for the sphere, but it should be fine for you lah because this is mathematics. Kai Qian, correct. Thank you. Right, dear? Calculate the mass of the sphere. Oh, mass. How can I know the mass? Here, first thing, relate weight. Can you finding the weight? From the weight, then we know the mass. Okay, so we can come back to the diagram here. Oh, they got tell us you see, 0.096, 0.096 Newton. Upthrust, just now you already calculate and you tell me 1 Newton. So do you able to find the weight? Find the weight and then tell me the mass. Like do it right now. And here keyword terminal velocity, meaning that force is balanced. So your upward force must be equals to your downward force. Jory. The second 0.1 behind this, is it 0.11? I get 0.11. You get 0.101. Yeah, 0.11, correct, Fawal. Washini, thank you. Jory? Jory, you check. Manjo also get 0.11. Good job. Right, dear? Because of this terminal velocity, so I know that upward force equals to downward force. It is balanced. Force is in balance. So at here, my upward force should be 0.096 plus 1 Newton equals to my downward force is my weight. So my weight should be 1.096 Newton. Your mass W equals to mg. 1.096 equals to m 9.81. So m should be 0.11 kg. Okay, this is the number 2, question number 2. Like Jory, what is the mistake? Press your calculator wrongly. Okay, Kai Qian, correct. 0.11 kg. This is the answer. So can you see that we find from the sentence to find the keyword is so important. If you don't know that this is a balance force, then how you solve the question? And then if you don't know that it's falling down, drag force is oppose your motion, then how you find the continue all the questions? Cannot. So please read the question. Do not skip any sentence. Do not skip any sentence. Okay, like boys and girls, we look at this. Find the keyword. See, floating, equilibrium again. So the forces will be balanced. Okay. Find the keyword. So 21%, this one 21%. Okay, that means that this part actually is 0.21 of the volume. Okay, it's below the surface. So this volume should be the volume of the immersed part, which means that later on the buoyant force equals to rho GV. This is the immersed part. It should be 0.21 voltage. So what voltage? 0.21 volume. Okay, here. Can you calculate the density of the sphere? So at here, density we know that is mass divided by volume. Okay, volume. We want to know the volume. We can relate it with buoyant force, right? Buoyant force got rho GV volume. But then buoyant force at here, because it's floating, so buoyant force should be equals to the weight. So this one going down is the weight. Going up actually is the buoyant force. mg. G and G can be cancelled. So at the end, your mass, your 1050, the volume is 0.21 V equals to your mass M. Okay, so you can do substitution for your M at here is 1050 times 0.21 volume divided by the whole volume of the object. Because this is density of the sphere. Okay, so mass of the sphere and volume of the sphere. So the volume no need to take the 21%. If we calculate the density for the sphere. Okay, so at here, volume and volume cancel out. So we do substitution, we should be able to get 220 kg per meter cube. This is the immersed part. Volume that the object immersed, it should be 0.21 volume. Oh, you round to 221, that means that three significant figure, no problems. 2 to 3. But most of the time, answer scheme is two significant figure. That's why I always ask you to round to two significant figure. 2 to 3, no problems. Okay, so here. Any question? Here I want to emphasize is the rho GV, this part V, it should be the part that immerse. Okay, the volume that the object immerse. Okay, next. The sphere is now, we hold it. So that is entire volume is below. Oh, right now they want it to be below. So somewhere like this. The sphere is then released. Okay, that means that we push it down. We push it down. We release. Where the sphere will go? Of course, the sphere will going upward, right? Okay, starting stationary like this. Then we push it in until it's fully immersed. Then after that we release. So the sphere, of course, it will moving. Okay, it will go up. So they want you to calculate the acceleration. This one A. Okay, so at here acceleration is net F equals to ma. F equals to ma. Okay, so the net force at here, this one we got the weight. Okay, then what else? We got the buoyant force. At here, the buoyant force is already changes. Okay, already changes. Why? Just now at here, this one we only immerse this part. So just now I told you that if we continue going down, we immerse more part, that means that the buoyant force will increase. So at here, this one, the buoyant force is rho GV. The rho GV, the V at here is the whole part already. Whole part of the volume. Okay, so at here, the buoyant force, net force, it should be buoyant force minus the weight. Buoyant force already increases because fully immersed equals to ma. Buoyant force is rho 1050 9.81. The V at here, because fully immersed, so we write V minus the weight. Weight is mg. M, our mass. Oh, okay. So this one is rho. W actually is mg. M actually is rho V. Rho V. Yeah, rho Vg. So this is what we learned today lah. Okay, density equals to mass divided by volume. So if we're finding the mass, actually we can using density V, density times V. So the density for the sphere, 220. So this one is 220 V times the 9.81 equals to M. M is the mass. Wow, again, 220 V. This is mass. This is mass. Times the A. Like boys and girls, try to do calculation. Well, this question, quite a lot of things have to think. It involves with what we have learned today. So many things that we learn. Like boys and girls, find your answer and then tell me. Volume and volume can cancel out. Ah. Oh, good job, Kai Qian. Vashini, correct. When we push it down, buoyant force will change because more volume of the object immersed in, more liquid will be displaced. So at here, we fully immersed. Entire volume is below the surface of water. So right now, our buoyant force, the V is the whole V. And then buoyant force increase, of course, your weight will increase. Of course, buoyant force increase. Of course, the buoyant force greater than the weight, so it will moving upwards. So we're using buoyant force minus the weight. Fatima, correct. Manjo, correct. Okay, so at here, the weight at here, we have to think, wait, what is the weight? I don't have any weight. So right now you have to think, apply the knowledge about the density part. So at here, the mass M equals to rho V. M equals to rho V. M equals to rho V. 220 V. The rho is here, the object rho. Okay, so this one apply and using the knowledge about the density already. Okay, so we combine a lot of knowledge in one question. Okay, here, so your answer for your acceleration should be 37 meter per second per second. Okay, boys and girls, we look at the last part. The sphere will accelerate upwards. Okay, but it remains entire below the surface, so it will going up lah. This is the direction of motion. Direction of motion. Okay, state and explain what happened to the acceleration when the velocity begins to increase. Okay, here accelerate means that velocity increase. I give you a hint. It's something like velocity increase, something will increase also. Like we were walking, we don't feel air resistance. But we start to run, we can feel the air resistance. So at here, this one also the same. When you start to accelerate, your velocity start to increase, basically your drag force will also increases. Okay, drag force is the force that always oppose your motion. For example, air resistance, we also can call it as drag force. So when velocity increase, drag force will also increase. So you think, when your drag force increase, what's going on with your resultant force and what's going on with your acceleration? Like boys and girls, type your idea. So this one, drag force is opposed motion. So use velocity increase. In another way, if we're running, so our speed increase, my air resistance will also increase. I can feel the air resistance. So in this case, also the same. Okay, so the sphere start to accelerate. Okay, initially there is no drag force. After that, the drag force will start to increase. So here, resultant force will increase. No, dear, no. Prasan, let me have a look. Yes, correct. Prasan, your idea is correct. Manjo, no? Manjo? Okay, here going up, buoyant force. So we got the weight. And because it's going up, this is direction of motion. So it will start to having a drag force here. It will start to having a drag force. So your resultant force basically, let me have a look at this answer. Resultant. Correct. But you have to start to, instead acceleration is not constant, but the first sentence, Fatima, first sentence is correct. Resultant force should be decreasing, correct. Acceleration decrease, yes, correct, Fawal. Vashini, resultant force decrease. Yes, correct. Vashini, correct. Like dear, because this one we start to having one more force oppose the motion, so buoyant force not only have to minus the weight, but it also minus the drag force, so your resultant force basically will decrease. F equals to ma, so your acceleration will also decrease. So this drag force, they will start to become bigger. This drag force, they will start to become bigger until at the end they balance. Upward force and downward force, they balance. So until they balance, actually they're moving with terminal velocity. Acceleration will become zero. So just now I say, Fatima, your second sentence is wrong. The acceleration is not constant. It will decrease until when they're reaching terminal velocity, acceleration actually is zero. Because terminal velocity means that constant speed. That means no acceleration. Okay, so at here, the drag force increases with speed. Okay, resultant force decrease. Okay, so because we have the drag force already, the upthrust and the weight still remain the same. So right now our resultant force will decrease. Acceleration decrease as its velocity increases. So here, when velocity increase, acceleration should be decreases. Why? This is the reason. Because drag force will start to have drag force, and this drag force will increases. Velocity increase, so drag force will increase. If drag force increase, the overall resultant force will start to decrease. So your acceleration will decrease. If we achieve terminal velocity, at the moment, acceleration will become zero. Like boys and girls, any questions? Fatima, okay. So Fatima, you understand about the second sentence? No question. Thank you. Okay, boys and girls. Next week we don't have lesson is because we already having 4 lesson this month, so already complete the tuition lesson 4 month, four lesson per month. So next week is the 5th Friday, so we don't have any lesson. But at the same I will preparing the, because we already finished this chapter, I will preparing the self-practice past year question for you and provided with the model answer. So you can do it and practice it, re-study and revise this chapter. Then after that, you checking the answer with the model answer lah. So next week, everybody relax. Next week's next week Friday we don't have lesson. Okay, then after that, okay, next question, page 8, because now our time is already over. Next question, page 8, question 5. After we stop the Zoom, after we end our meeting, Zoom meeting, so I will print screen the model answer for you. You continue practice the question number 5 on your page 8 and 9. I will just readily print out the answer scheme for you. Is it okay? Okay, next week no lesson, dear. Okay, Fatima, okay, Prasan, okay, Vashini, okay, Fawa, okay, Kai Qian, okay. Okay, dear. Yeah, we learned a lot today. You have to digest, okay, revise, and then cover the questions, and then you can redo again. If you're able to get the same answer, that means that you really learn it. Okay, so that's all for our lesson. After end of the meeting, I will print screen the question number 5. Okay, next week no lesson. Okay, that's all for our lesson today. Bye bye.